Hey everybody, this is Larry. This is day 28 of the Leetcode Daily Challenge in September. Hit the like button, the subscribe button, join me in Discord, and let's get started today's Subarray product less than K. Let me know what you think about today's problem. So you're given an array of positive integers nums, count and print the number of contiguous subarrays where the product of all elements in the subarray is less than K. Okay. Less than 50,000, so that means that n squared is going to be too slow. We're looking for linear or n log n. Okay, so I think the thing that I will think about is just the rolling window. I mean, in this case it's product and it's positive integers only. Those are the two things that I noticed, and that means that if you're trying to get a maximal subarray of product that is less than the K, that's how you would get it, right? But in this problem, you're trying to get the count. So we just have to make a small modification to it and then sum up the count. I think that should be okay. And I'll explain it as I go along with the code. But let's just start writing it a little bit. Basically, the idea that I want to use is called a sliding window or 2 pointers or whatever. Basically, so we have for 2 pointers, we have 2 pointers, right? A left pointer and a right pointer. For this problem, for each right pointer, we want to see what is the leftmost element that you can get that can still give you the product less than K. And because this is monotonically increasing, any subset of that will give you the count as well. Okay, so let's get started. So is there any zeros? Positive, okay. So basically, let's just start with running is equal to 1. It's almost like a prefix sum, but with product instead. So you can maybe do a prefix product if you want to call it that, or prefix sum on the logarithmic, or on the log of the number or something like that. But yeah, so that means so now let's have 2 pointers, right? Left is equal to right is equal to 0, or maybe left is equal to 0 for right in range sub n, where n is the number of nums, right? Okay, so now the running count should multiply by the num sub right. So now when you move the right finger, the right pointer to the right, what does this mean, right? Well, that means that now you have a range. So let me actually try to do a little bit of visualization. But let's say you have an array, and now what you want to do is keep a track of your pointers left and right, such that basically running is equal to the product of all numbers between left and right inclusive, right? And that means that when we move our right element 1, we are going to multiply, and then when we move our left element 1, we're going to divide. Cool. Okay. So now while running is greater than, does that have to be strictly, it's less than K, right? So that means that if it's equal to K, we still have to do it, yeah. So if it's greater than K, then, okay, let's start at 0, I suppose. And K could be 0, so we have to make sure we don't go over as a result. So we have to check if left is equal to right, and that. Then running divided by num sub left, right? Left increment by 1. Okay, so now we have the left range and the right range. You have to making sure that, so the invariant at this point is that we move the right one at a time, and then left we keep on moving to the left until a certain condition is met. That is the invariant, and at this point where I have it, the invariant is that the product will be less than, strictly less than K. So at this point, the invariant is that the product between num sub left times dot 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 num sub right is less than k, right? So then now, how do we count that, right? So let's say well, you know, left is at the 0. So in this case, left is 0, right is equal to 2. That means that all the backwards, all the suffixes starting from 2 is a valid subarray, right? And what does that mean? That means that in this case, let's say we could choose, let's just say k is equal to, I don't know, billion, right? Doesn't really matter. But that means that 2 is a good array. 2, 5, I'm doing this backward, but 2, 5 is a good array. 2, 5, 10 is a good array, right? And because we know this, because the product of 10 times 5 times 10 is less than this k, so that all the subarrays that ends at 2 to the left of 2 will be a valid subarray, right? So yeah, so that's basically how we keep on tallying. And because we move the right pointer one at a time, for every movement of the right pointer, we count the number of left pointers to it. At the end, when we sum everything up, we should get the right answer. So let's see. So right minus left. Yeah, maybe I'm off by 1 here actually, so I might have to double check. But these should be inclusive, so this should be this plus 1, except for when running is greater than or equal to k. Right, something like that. I was looking for more test cases, but it looks like it's not there. Cool. Let's try a few more test cases. And in the worst cases, you can kind of notice from these formulas, it's going to be n squared in terms of the final answer, not the running time. The running time we'll go over in a second, but you can also probably guess that it is linear. Okay, so that looks pretty okay. So I'm going to submit, maybe. Let's add a 10,000 here, just for funds. Ooh. Oh, whoops. Okay, fine. I didn't look at the input. Let's add, yeah, something like that for fun. Okay, so that looks good. I'm going to submit. Hopefully there's no weird edge cases. Okay, looks good. Yeah, so what is the running time? What is the space complexity? Well, the running time is that, you know, for each number in this array, in the input array, we are going to multiply once, and we're going to at most divide it once, right? So that means that each element will be multiplied once and divided once. That means that it will be over one operation, even though this while loop might not look it. That's how we're going to analyze it. And because of that, this is linear time. In terms of space, if you look at this entire thing, everything is like variable. There's no arrays or anything. So it's going to be over one space. So yeah, so this is an application of the sliding window. And this kind of prefix question or suffix question or prefix question, about how you want to call it, does come up here and there. There are a couple of variations of this problem in Leetcode, and I would urge you to kind of play around with it until you are familiar with it. It does come in play. One variation may be, get the max length array such that the product is less than k. Count how many of it contains at least 3 numbers. So there are a lot of conditions like that where most of the code will be the same, but it all comes down to how you count the elements, or what you keep track of, or what I call bookkeeping. Cool. That's all I have for this problem. Let me know what you think. Yeah, let me know what you think. Hit the like button, hit the subscribe button, join me on Discord, and I will see y'all tomorrow. Bye bye.